So this is let me delete this. So the acceleration is changing velocity v2 minus v1, for instance, over time. Now, changing velocity will still give you velocity. So this will give you velocity over time. Oh, sorry, I wrote 2 instead of t, over time. And remember, velocity is what? Meter per second. So we have meter per second. Or let me write it this way. Let me not write it like that. Let me write it this way. Meter per second. Remember? Then over second again, because that is just velocity, but over time. So this will be meter per second times 1 over second. And this will give us meter per second square, which we can write as meter per second square. So that's why we get this as the unit for acceleration. Okay, so now I can see my board is getting full. So let me delete this. Okay, let me just highlight it and delete it at once so that we can have a clean board to work with. Now we have force. We have force, which is mass times acceleration. So is the unit for force is Newton, but the equivalence of Newton is mass is kg meter per second square, since acceleration is this and mass is this. You understand? Now, the unit of volume is obtained by multiplying 3 lengths. So we've explained this. There'll be no point explaining this again. So let me just leave that. Now, difference between fundamental and derived units. So fundamental units, we have a table here. This is fundamental units and this is derived unit. And we're going to explain the differences. Now, they are standard units of measurements. Fundamental units are standard units of measurements, while derived units, they are not standard units of measurements. So remember this, remember these things. You might be asked in an exam. They are generally accepted. Sorry about that, I have a little sore throat. They are generally accepted all over the world. Not all are generally accepted all over the world. That's for derived units. So we also have, they form the basis of measurement. Derived units, they are not the basics of measurement. And then fundamental units, they are accepted by international organizations. Now, derived units, though accepted internationally, they are formulated by individuals. And number 5, finally, okay, that's not the final one. I think we have others on the next page. So fundamental units are known as SI units. Yeah, good. I'm correct. We have others on the next page. Are known as SI units. International system. That is international system, right? While derived units, they are known as units. Now, differences between fundamental and derived quantities. So the differences we highlighted above are the differences between fundamental and derived units. Why now we are highlighting the differences between fundamental and derived quantities. Now, fundamental quantities, they are generally accepted. So this is similar to what we discussed about the units. They are just accepted or not generally accepted. That's for derived quantities. And you can see through this is self-explanatory, so I will not go through all of them. Okay, but let me just mention them. They are based on international system. They are formulated from international system. Now, for the fundamental units number 3, they can stand alone, but derived units cannot stand alone. They actually need to be expressed by fundamental units. They actually need to be expressed by fundamental quantities, since we're dealing with quantities. Number four, they have direct calculations for fundamental quantities. For derived quantities, their calculations are derived. So for instance, if you want to calculate force, you are going to calculate mass times acceleration, because force is derived from mass times acceleration. If you want to calculate acceleration, you are going to calculate um, velocity over time. If you want to calculate velocity, you are going to calculate displacement over time, right? So you see that. But if you want to calculate time, you are just going to measure time. Do you understand? So this is a fundamental quantity, while the rest of what I did here are derived quantities. Now, they are basic units of measurement. That's for fundamental quantities. While derived quantities, they are not basic units of measurement. Now, dimensions of physical quantities. Okay, so here we are going to be explaining dimensions of physical quantities, and this is where we um, derive units. So we are going to be explaining um, the dimensions of derived units. Now, the dimension of a physical quantity is the way it is related to the quantities of mass, length, and time. The way a quantity is related to the quantities of mass, length, and time, or in other words, the way a quantity is related to fundamental quantities. Now, the dimension of unit mass is m, for unit length L, and for unit time T. So you see the table below, we have quantity mass, the unit is kilogram, the dimension is m. The quantity length, the unit is meter, the dimension is L. The quantity time, the unit is seconds, and the dimension is T. So how are quantities related to these quantities? How are dimensions related to these dimensions? And that's what we're going to be discussing in this section. And this subtopic is what we call dimensional analysis. So when you hear about dimensional analysis, we are just analyzing different dimensions to see how they are related to MLT, to kilogram, meter, and seconds. So the first quantity here we have is density. Now, this is mass per unit volume. That's the meaning. Density is mass per unit volume. And the dimensional equation of density is gotten from the analysis below. So since density is mass per unit volume, we can say that is kg per meter cube, right? Kg per meter cube. Now, kg is kilogram, is the dimension is m, and meter, the dimension is L, so meter cube will be L cube. And this will now give us ml minus 3, because that's the meaning of m over L cube. You understand? So this is what we just derived. It's that simple. It's actually nothing complex. Once you understand this table and you know the formula for the quantity you are discussing, then you just put in these values, relating them to the formula to produce the dimension of that quantity. Okay, so let me also, okay, should I delete this? Okay, instead of deleting this, right? Instead of deleting this, I will just minimize it. No, that's not my tool for minimization. I can't remember the particular tool I used to minimize this, right? Okay, it's not in this, application. Okay, so what I will do instead is, let me just pack this. I'll pack all of them to another side so that I can have space. Okay, let me pack them up. Let me bring them up. Okay. So I think we have some space here. We can go back and look at them if we need to. Now we have velocity. Velocity, this is the rate of change of displacement with time. So the rate of change of displacement with time, we already mentioned something about this. So, displacement is length. So we have length over, so the rate of change in length will still be length, over time, which is t, and this will give us the dimension for length is what? L. Why the dimension for time? Okay, so I wrote L here already, but the dimension for time is S. So I should, okay, in that case, let me just delete this, right? So we have L over S, and that will give us, no, what am I saying? I think I'm missing this, I'm mixing it up. So the dimension for displacement is length, but the dimension is, the dimension for displacement, why am I seeing M here? I think that was a mix up. Okay, that was a mix up. So it's L over S. Oh, that was a serious mix up. Okay, the dimension for this is L over the dimension for time is T, and this will give us LT minus 1. So this M here stands for, okay, meter per second. Meter, displacement is meter, time seconds. So that's meter, and the time is seconds. And this is equal to, meter is measured in, the dimension for meter is L, the dimension for seconds is T. Yeah, I get. You understand? Yeah, sometimes those things happen. All right, so acceleration, this is the rate of change of velocity with time. The rate of change of velocity with time. So velocity is meter per second, right? And time is seconds. So meter per second, okay, we have velocity here. We have the dimension for velocity. So that's LT minus 1 over T. So this will give us LT minus 2, because this is like L over T all over T. So this will be L over T times 1 over T, which will be equal to L over T squared, which is the same as LT minus 2. You understand? So that's why we got this. Okay, let's minimize this a little bit so that we can pick this up and take it away. So let me just drop this over here, right? Sorry about that. And let's come back to, okay, we're actually done with this page. So no, this video is getting long, so let's not move to the next page. Let's cut from here.